Good morning, everybody. This is Ben Jones here from Badger from Bronson Coffee Roasters, and today we're going to be doing something a little different. I'm just going to be using my hands. Last week and earlier this week, we talked about some different things about strength and extraction yield. So, quick little recap here. Let me just move out the paper that I'm not using immediately. All right, so we're going to put some things together. Strength. This is the question of how much coffee flavoring do we have in our beverage. The range we're going to be looking at is essentially 0, which is pure water. And then let's just go and bring this up to the top, and we're going to call it 2% coffee flavoring. And that's a pretty potent cup of coffee at 2%. I don't know many people who want to drink a mug of coffee with 2% coffee flavoring. That's mighty strong. So, but also because we're looking at the 2% flavoring of coffee in the water, this means we're working exclusively in the range of drip filtered coffee. It doesn't be drip, I suppose, just any type of filter coffee, something you might do from the AeroPress, the Chemex, a auto drip brewer, even a French press. What this does not reflect would be espresso, mocha pot, things that are going to be heavier and more syrupy. All right, so strength. This is, again, the question of how much coffee flavoring is there. And I'll just put that midpoint. There's our 1%. There we go. And along the bottom, we're going to put a line, and this is our yield, our solubles yield, or our extraction. So this is how much of the weight of the bean did we pull out and put into the coffee. So if we added in 100 grams of coffee beans, what is the added weight into the coffee that we took out of the coffee bean and put in as flavor? So here at 0 and 0, we have pure water. And then, on the long end, we're looking at approximately, let's just say, just for kicks, that 30%, 1/3 of the coffee we can pull out of the weight of the coffee bean can be dissolved in water. The rest of it is not soluble in water. It's woody structure. It's things of that sort. And I apologize that I don't get to have my nice shiny face today. I can't write this much backwards with the camera being in mirror mode. Anyway, so what we're going to do is we're going to look at our recipe now. We're going to look at how many grams per liter. So grams per liter. This is a pretty common measurement for brewing coffee. It is metric, so we Americans need to, just get used to that. It's a really great way when you're working with coffee, because the gram is much more useful than the ounce. So there we are. All right, so let's just say that we're gonna make a cup of coffee and we use our scale and we weigh out. Let's just say that I'm gonna make a cup of coffee that's gonna have about 30 grams per liter. All right, that's not very much coffee. Let's put it onto the high end, and let's just say we're going to make a very strong cup of coffee, and we're going to put in 80 grams per liter. This is kind of cool. The way we plot this out is, let's go from our 0, 0, our pure water, and then from water, as we let those beans steep, they begin to give up the flavor. And the same thing here. We're going to, I can't move things apart. I'm just going to give a quick little, I think I have some coffee bits on the counter. All right, over here, same thing. 30 grams, starting at pure water, dissolving all of that in there. This is kind of cool. With 30 grams going into a liter, if we maximize our extraction, we're not going to be able to really get 1% of strength. there's just not enough soluble material in this little bit of coffee, so it's going to be on the weaker end of the spectrum. With 80 grams going in, before we've really extracted very much, so we have a low yield, we can be at a really high strength. That's just something to make note of. Let's toss a few more in here, because I'll tell you right now that 30 grams per liter, 80 grams per liter is not delicious. Let's just go ahead and say that we're going to do, standard brews put us at about 60 grams, maybe 55 grams per liter, or even 50 grams per liter. And then if we go ahead and graph that, we get our extraction yield and our strength curves. Or strength graph. There we go. So roughly that's how it goes. Spoiler alert, this tends to be our recipe. If you're brewing coffee, you want to use, for every liter of water, 50 grams, 55 grams, or about 60 grams for every cup of coffee. And that's just sort of the general accepted preference. You might be wondering how we got to these numbers. In this study, coffee was brewed for quite a large sample group at all these different strengths. So they took 30 grams per liter and they brewed it at various time points to get different extraction points. Then they went ahead and compiled all the information about, who's liking what's tasting really good. And what they found was, let's see, I'm going to add in a few more little points here. So this is 1.5. This would be 1.25. This is our 1%, 50%, and this is going to be the 0.75. All right. An extraction yield, if we have 30%, this puts us at 15, 20, 25, and there we go, 10 and 5. All right. Filling out our graph. This is all that high school math that you never thought you would use coming into play. So what happened is the people doing the study, they said, hey everybody, what coffee's tasting really good to you? And imagine if everyone participating in the study was given a little coffee bean and they said, go ahead and pick which one you like. Some people might have liked this one, some like this one, but the bulk of people, there was a concentration right there, and that is about the range where people tended to like the way the coffee tasted. So what do? We take our ruler and we say, oh, cool, all right, so this line about right here and about right here, that tasted really good. People liked that a lot. We do the same thing over here, and we get this nice little box that is considered, this is the target area where most people were happiest. Kind of cool. All of this other outlying area, we don't really like the way the coffee tastes there, so we're not going to use it. So this whole thing, we're going to take this and let's just zoom in right there on that area that people tended to like, and that brings us to our coffee control chart. This is from the Specialty Coffee Association, developed back in the 70s. There is a new model that's being worked on. It's a 3D model that brings in like different flavor profiles, so bitterness, sweetness, all those types of elements. Right here in the center, in the shaded square, this is our optimum balance. And if we look at which line spends the most time in here, from here to here, we have our 55 grams per liter recipe, which spends the majority of the time in the optimum balance. That's where more people like the coffee than anyone else. So if you're brewing coffee and you hit this 55 gram per liter recipe, you're going to have a better chance of having a good cup. We're not going to as easily over extract. We're not going to as easily under extract. And then also our risks of going too strong or too weak are minimized. And I like this graph a lot. What I like about this is that it's just a real simple way to look at, all right, if our x-axis, our right and left, is how much stuff are we pulling out, what flavors are we getting, this is all, everything on this side, this is all that really nasty, carbony, burnt matches, rubbing alcohol, astringency, those things that are very nasty in a specific way. On this side, the under-extracted, or ones that, you know, like if you're thinking, I like to think of this kind of right-left in terms of baking cookies, baking bread, cooking a steak. On this side, it's going to be underbaked. So you might have had your oven set to 350, you might have had your skillet or your grill set nice and hot, but we didn't give enough time to develop all the flavors to the point that we like. Flavor-wise, over here, where you'll be getting an incredibly raw steak, a very doughy loaf of bread, very soggy, mushy cookies. In coffee, it tends to taste of overly sour, overly tart. It might taste like a stick of pine boiled in water. It might take on some cocoa bitterness or some vegetal bitterness. But then as we start to push into the optimum balance, we begin to get sugars that come in and we start to extract sugars. If we go too far, we're looking at burnt matches, rubbing alcohol, astringency, medicinal. The up and down is how intense is that going to be? Is it going to be intensely delicious? So much so that it's actually too intensely delicious, maybe too strong. Is it going to have good flavors, but they're really diluted with too much water? That's where we're down here. So we have, if we go around this, let's just start up here. Strong and underdeveloped taste. This would be too much ground coffee used, not enough steep time. So we let it steep a little bit longer. We have the most flavorful development. It's tasting good, but it's too intense. And at this point, you can correct it by diluting with some water, but it will kind of change some of the profile. This is sort of the way I brew AeroPress. I make a too strong but appropriately brewed cup of coffee. But then by adding some water, it pushes it into the thing. So Scott has a question here. He's asking, does the optimal balance change depending on the brew method? No. Certain brew methods you'll find can more easily come into different areas. Some give us more control. It's all going to be dependent on grind size, water temperature, but primarily exposure time. So if we're using appropriately hot water, we want to match our grind size to the exposure time. And then that'll give us this right-left for the extraction yield. The Y column, the Y-axis, is going to be how much coffee are we using with water. So in some ways, yes, your brew method can vary. For example, if I'm brewing on my Melita cone, this requires a specific range of grind size, which is going to necessitate a certain brew length. It'll take about typically 2.5 to 3.5 minutes for the water to pass through that. So I want to make sure that I have a coffee grind that will not over extract at 3.5 minutes and will not be under extracted, the same thing. One of the reasons I really enjoy things like French press, AeroPress, the full immersion brews, Clever Dripper, is that we can control how long it steeps for. So Scott, I hope that helps. This chart, again, suited for regular drinking mug style coffee, not espresso, not stovetop espresso out of a mocha pot. Cold brew, a little bit different, but a little bit closer. So we're talking classic filter coffee, French press, auto drip, Chemex, Clever, AeroPress, things of that sort. Awesome. All right. Cool. So strong, but overly developed. So this is too much lemon, too many bitter greens, too much baker's cocoa. All right, so we keep brewing. We let that stay in contact longer and longer and longer. We develop a higher extraction yield. Now it is strong and over extracted. So up here, it's going to taste too much like burnt matches, too much like rubbing alcohol. It's going to be intense. If we add water to it to dilute the strength, fine. We drop the strength down, made it a little more palatable, but it still is going to have those primary flavors of burnt match, rubbing alcohol. Not delicious. If we're using, let's just say we're using a very finely ground coffee, hypothetical, you go to the cafe, you buy a pound of beans, and you ask to have it ground for espresso, but then you end up trying to brew it in a clever dripper. It's going to be over extracted, and maybe you added too much water to your brew. So this is going to taste like watered down rubbing alcohol and burnt matches. Coming back around, appropriate recipes, so it's going to have a nice balance, but it's just going to be too watered down. Weak and underdeveloped, so very much watered down, sour, not super delicious. Over here, strength-wise, in this middle column on the left, we're looking at the intensity is fine, but the flavors aren't very pleasant. So optimum balance, we're getting appropriate amounts of bitter, sweet, and sour all pulled together. And that's really what we're looking for, is we want to have that balance. Just gonna, real quick here, what we really want to get as we're brewing, the first things we're going to be getting is we're going to be getting some bitter, because we're going to have like some of the cocoa elements. We're going to be getting some sour. Those come out really early. Bitter, again, cocoa, bitter greens, maybe even a little bit orange pith, like if you try to eat the white fleshy part between the fruit and the peel, you get some of those flavors by themselves, not very good. But the acids that we get help to balance that out, helps to kind of neutralize, and they balance each other out. But with anything, if you're making lemonade, straight lemon's going to be too sour. If you're eating straight cocoa, it's going to be way too bitter. And how do we fix those? We add some sugar, and that is going to be the next part in that phase. And anytime you have a table with 3 legs, it's going to be solid and sturdy. And this is our balanced extraction. So what we're hoping for is all 3 of those in balance. That's this portion, but then using the right amount of coffee and water. I can talk about this way too much, so I'm going to leave you with 2 pieces. One, I think this is fascinating, that our extraction yields for ideal extraction, based on this research, 18 to 22%. It's a fairly narrow margin. But to me, what's really fascinating is if we look at our strength. Remember, strength is the amount of coffee solids, the actual coffee material, in water. At the low end of pleasant, we have 1.15%. At the high end of pleasant, we have 1.35%. So we're looking at 0.2% in flavoring shift that'll kick us into or out of a pleasant experience. Much below 1%, we don't taste the coffee very much. And really, if we start hitting 1.4% flavoring material in the coffee, it's too intense for us to enjoy. Coffee is an incredibly powerful and efficient flavoring agent, and it's pretty rad. The final thing I want to leave you with here is, this is really where we all want to be, that optimum balance. If you had to drink a cup of coffee outside of these parameters, let's just go to the extreme corners. Would you rather have an over-extracted cup of coffee that tastes of burnt matches and rubbing alcohol and is very strong? Or would you like to have a weak burnt matches, rubbing alcohol, very strong sour and bitter, or very weak sour bitter? I'll tell you, this is my least favorite, overly strong and over-extracted. that's when you leave that French press sitting on the counter for way too long, and for, you know, with not enough water going into it, it's pretty intense. I think if I had to choose one of the extreme pieces, I'd probably go, well, it's a toss-up. Depending on the coffee, if it's something really too vegetal, I don't want this. So if I'm looking at Central South Americans, I want to go over extracted. If I'm looking at some African coffees, Kenyans, Ethiopias, make it weak and under extracted or and strong. Anyway, Scott, strong sour bitter. So you're up here. That's not a bad place to be too. So that was kind of my next guess. I really want to stay out of this area. This is just really harsh. All right. So thank you all for joining. It's up here in the Northwest. It's going to be a hot weekend. I will not be back Monday because I have a meeting too early in the morning to be catching a 9 a.m. video. But this is some pretty cool stuff. And if you're really into it, this is one of my favorite books. You can see how torn and tattered it is. It's the Coffee Brewing Handbook, published by the Specialty Coffee Association of America. You can find partial bits and pieces online that have some of the really fun stuff. If you're really interested in it, go to the SCA website, and they do have those in the stores. And well, y'all can get clever out there and find some things. Anyway, it's good stuff. Thank you for joining. Remember to shoot for 50 to 60 grams per liter to get us into this optimum balance, and that just happens to be that the ratios play out roughly 1 to 17, 1 to 15, thereabouts. So, all right, I'm going to leave you all and catch you next week.